What is a mole? The mole is simply a counting unit. Well then, what is a counting unit? You actually already know a lot of counting units, but you haven't probably used the term counting unit. Here's an example of a counting unit that you already know. I have 2 gloves. They're pretty nice gloves. What word can I use in place of the number 2? I have blank gloves. That's right. I could say that I have a pair of gloves. The word pair is a counting unit. Let's try another one. Here are some eggs. I have 12 eggs. What counting unit can I use instead of the number 12? I have blank eggs. That's right. I have a dozen eggs. The word dozen is a counting unit. A counting unit is just a word that means a specific number. So back to the mole. The mole is simply a counting unit. It refers to a specific number. But what is that number? It refers to this number. That's a huge number. It's so large, in fact, that we should use scientific notation to write the number. Here is a number for a mole in scientific notation. A mole is 6.022 times 10 to the power 23. The mole is such a large number that it's difficult to comprehend. It's huge. But here's a challenge for you. I'm holding a $100 bill. If I were to place a mole of $100 bills end to end, how far would the mole of bills reach? Let me be clear. I am holding a strip of a dozen $100 bills placed end to end. What if I had a mole of $100 bills placed end to end? How far would they go? Maybe from New York to Los Angeles? Longer than that. Think again, how long would one mole of bills reach? Maybe to the moon? Farther than that. It turns out that one mole of bills would stretch from one end of our galaxy to the other end of our galaxy. I mean, that's impossible to imagine. It's hard to even put your head around that. Except in this case. I have a mole of something in my hand. Can you guess what it is that I'm holding? Here's a hint. It's not very heavy. In fact, it's only 12 grams. If you said atoms, you're correct. If you said carbon atoms, then you're amazing, because I do have a mole of carbon atoms in this jar. Why do you think a chemist uses a mole? 6.022 times 10 to the 23rd as their counting unit. It's so huge. Because atoms are really small. In this case, a mole of carbon atoms fits nicely in my hand. But where did that strange number, 6.022 times 10 to the 23rd, come from? I mean, why didn't scientists round the number to something more easy to remember, like 1 times 10 to the 23rd? Wouldn't that be a lot easier? Why 6.022? Well, the answer is actually in my hand. It turns out that I'm holding the definition of a mole in my hand. This jar contains a very pure form of carbon with exactly 6 neutrons and 6 protons in each atom's nucleus. In other words, this is carbon-12. And this jar is holding exactly 12 grams of this special type of carbon. Why would I do that? Because the current definition of a mole is the number of carbon atoms that you'd have if you had 12 grams of carbon-12. That's exactly what I'm holding in my hand. You see, if I were to painstakingly count every atom in this 12-gram sample, I would have 6.022 times 10 to the power 23 atoms. Who decided that the number of atoms in this jar would be the definition of a mole? The answer is the International Bureau of Weights and Measures, which is an international standards organization. The mole, abbreviated MOL, for those who don't want to write out the E, is the E really that tough? I mean, well, anyway, the mole is an official SI unit. And before I let you go, though, I want to let you know that the mole is sometimes called Avogadro's number, in honor of an Italian physicist, Amedeo Avogadro. So if someone refers to Avogadro's number, they are referring to the same number as a mole, 6.022 times 10 to the power 23. But I prefer to say I just have a mole. It's just easier to say. No offense, Avogadro.